This video is about sinusoidal modeling. That's where you use a sine or a cosine function to model a particular situation. This is AP Precalculus topic 3.7. If you appreciate this content, please give it a like. Number 13. The function f is defined by f of x is equal to a times the sine of b times x plus c plus d for constants a, b, c, and d. In the xy plane, the points 4, 1 and 8, 5 represent a minimum value and a maximum value respectively on the graph of f. What are the values of a and d? The d value is the middle value of a function, so it is the average of the maximum value and the minimum value. In other words, it will be the maximum value plus the minimum value divided by 2. In this case, the d value will be 5 plus 1 divided by 2. This is half of 6, which equals 3. The a value corresponds to the amplitude, except sometimes the a value could be negative. In this case, the a values are all positive, so the a value will simply equal the amplitude, which equals the maximum value minus the middle value. In this case, the maximum value is 5, and the middle value is the d value we just found. So the a value and the amplitude is 5 minus 3, which equals 2. This corresponds to answer B. Number 14 is basically the same question with a new minimum value and a new maximum value. The d value is the middle value, so it'll be the average of the max and min. So in this case, the d value will be 1/2 8 minus 4. 8 minus 4 is 4, and half of 4 is 2. So d is equal to 2. Since all the a values are positive this time, the a value will simply equal the amplitude, which will be the maximum value minus the middle value. In this case, the maximum value is 8, and the middle value is the d value we just found. And 8 minus 2 is 6. So that's the a value. This corresponds to answer C. Number 15. The function h is defined by h of x is equal to a times the sine of b times x plus c plus d for constants a, b, c, and d. In the xy plane, the points 0, 0 and 2 pi, 6 represent a minimum value and a maximum value respectively on the graph of h. What is the value of b? In a previous video, we learned that the period is always double the horizontal distance between consecutive max and min. In other words, the period is always double the difference of theta 2 minus theta 1, where theta 2 and theta 1 are the input values of consecutive max and min. In this case, the period will equal 2 times 2 pi minus 0. And I'm not going to write the minus 0, so the period is 2 times 2 pi, which is equal to 4 pi. The period will help us find the b value because we have memorized that the b value is always 2 pi divided by the period. So in this case, the b value will equal 2 pi divided by the period of 4 pi. The pi's cancel out, leaving 2 over 4, which equals 1/2. So the answer is A. Number 16. The function k is defined by k of x is equal to a times the cosine of bx plus d for constants a, b, c, and d. Well, they didn't say c. C is 0. We know this. In the xy plane, the points 0, -4 and 4, 4 represent a minimum value and a maximum value, respectively, on the graph of k. What are the values of a and b? I think a sketch will be very helpful for number 16. We are told that k of x is a cosine function with a minimum value at 0, negative 4 and a maximum value at 4, 4. So that gives us this upside down cosine function shape. Halfway between 4 and negative 4 is 0, so the midline is the x-axis. The amplitude is the distance between the midline and the maximum value. So the amplitude is 4. This will give us an a value of either positive 4 or negative 4. Since we have an upside down cosine function compared to the parent function, the a value should be negative 4. Now we need to find the b value, but in order to find the b value, we need the period. The period will always be double the horizontal distance between consecutive max and min. So the period will be 2 times theta 2 minus theta 1, where theta 2 and theta 1 are the input values of consecutive max and min. So in this case, the period will be 2 times 4 minus 0. 4 minus 0 is just 4, and 2 times 4 is 8. So that is the period. Now we know that the b value will always be 2 pi divided by the period. So 2 pi over 8. This reduces down to pi over 4. Answer C is the one with an a value of negative 4 and a b value of pi over 4. Number 17. Point P is located at the end of a large gear. At time t equals 0 seconds, the point P is directly below the center of the gear and is 4 inches above a level surface, as shown in the figure. Point P is 6 inches from the center of the gear. The height of point P in inches above the level surface is periodically increasing and decreasing as the gear rotates at a constant speed in the clockwise direction. The gear completes 1 revolution in 2 seconds. Which of the following could be an expression for h of t, the height in inches of point P above the level ground at time t seconds? Point P starts here at its lowest height above the level surface, a height of 4 inches. Then it begins to rise. At a certain time, it's going to reach its middle height, which will be 6 inches above its lowest height. So 4 plus 6 is 10, so the middle height will be 10. Eventually, it will reach its maximum height, which will be another 6 inches. I mean, the radius is 6, so it'll be 6 inches below the middle value and then 6 inches above the middle value. So that maximum height will be 16. So again, the point P starts at its lowest value, it rises through the midline to its highest value, and then it will begin to fall back down to its lowest value. So we have this upside down cosine function. These are all upside down cosine functions, so this is making sense so far. All of the d values are in the front for some reason, so I just want to be clear that, for example, option A could be rewritten as negative 4 cosine 2t plus 6. So this 6 is the d value, and in the case of option B, the 10 is the d value, in option C, the 6 is the d value, and in option D, the 10 is the d value. The d value represents the middle height of point P, and we just calculated that the middle height would be 10. Therefore, we can eliminate options A and C, which have a d value of 6. We can choose between options B and D by calculating the b value and see which one is a match. But in order to find the b value, we have to start by finding the period. We are told that the gear completes 1 revolution in 2 seconds. So that's the period right there. Now the b value is always going to be 2 pi divided by the period. So b will equal 2 pi divided by 2. The 2's cancel out, leaving a b value of pi. That corresponds to option D, which does have a b value of pi. Number 18. A game show uses a large spinner of radius 15 feet that rotates at a constant rate to determine which prizes contestants win. The figure above provides a representation of the wheel in the xy plane with the direction of rotation indicated. At time t equals 0 seconds, the spinner begins to rotate. Point P on the wheel is at the start position in the figure. At time t equals 5 seconds, 20 rotations of the spinner have been completed, and P is in the same position as it was at time t equals 0. A sinusoidal function is used to model the x-coordinate of the position of P as a function of time in seconds. Which of the following functions is an appropriate model for this situation? Remember, we are building a function f of t to model the x-coordinate of point P. So at time t equals 0, right here at the start, the x-coordinate of point P is 0. Point P is on the y-axis. So the x-coordinate starts at 0. Point P then rotates in this direction as indicated by the arrows and will soon reach this location that has an x-coordinate of negative 15. So point P will next have an x-coordinate of negative 15. The rotation continues until we get to this point on the circle where point P has an x-coordinate again of 0. So we are back to an x value of 0. As the rotation continues, eventually point P will reach this location, which has an x value of positive 15. And then as the rotation continues back to the starting position, the x-coordinate is back to 0 again. As you can see, the values of the x-coordinate decrease and increase in this upside down sine curve pattern. So we will have to have a model that has a negative a value because this is an upside down sine curve. So we can eliminate options C and D, which have positive a values. These would give a right side up sine curve compared to the parent function. The remaining options A and B have different b values. So let's calculate the b value based on the given information and see which one of these is a match. To find the b value, we first need the period. The period will be the duration of one rotation. We are told that 20 rotations occur in 5 seconds. So we can figure out the duration of one rotation by dividing both sides by 20. One rotation will take 5 divided by 20 seconds. 5 over 20 reduces down to 1/4. That tells us that the period is equal to 1/4 of a second. We have learned that the b value is given by 2 pi divided by the period. So in this case, the b value will equal 2 pi divided by 1/4. But when you divide by a fraction, you multiply by the reciprocal. So b will equal 2 pi times 4. So b turns out to be 8 pi, which corresponds to answer B. Number 19. A game show uses a large spinner of radius 15 feet that rotates at a constant rate to determine which prizes contestants win. The figure above provides a representation of the wheel in the xy plane with the direction of rotation indicated. At time t equals 0 seconds, the spinner begins to rotate. point P on the wheel is at the start position in the figure. At time t equals 10 seconds, 30 rotations of the spinner have been completed, and P is in the same position as it was at time t equals 0. A sinusoidal function is used to model the y-coordinate of the position of P as a function of time t in seconds. Which of the following functions is an appropriate model for this situation? This situation is very similar to the previous problem, except this time function f represents the value of the y-coordinate. So at time t equals 0, point P is at the start, which is a y value of 15. So at t equals 0, we are starting at the maximum y value of 15. The rotation is in this direction, so the y value will decrease to 0 before decreasing further to its minimum value of negative 15, before it begins to then increase back to a y value of 0, until finally increasing all the way back to its maximum y-coordinate of 15 again. Hopefully you recognize this as the shape of a right-side-up cosine function compared to the parent function. So we're looking for a function that has a positive a value. All of these have a positive a value, so I guess that doesn't really help us. I'm noticing that they all have different b values. So let's calculate the b value based on the information given, and then look to see which function is a match. For the b value, we start by finding the period. The period is the duration of a single rotation. We are told that 30 rotations took 10 seconds. We can find the duration of a single rotation by dividing both sides by 30. So one rotation will take 10 divided by 30 seconds. In other words, the period is 1/3 of a second. We know that the b value is given by 2 pi divided by the period. So in this case, that's 2 pi divided by 1/3. But when you divide by a fraction, you multiply by the reciprocal. So b will equal 2 pi times 3. In other words, b will equal 6 pi. Aha! That corresponds to answer B. Number 20 is almost the same as number 19 and number 18, so I'm not going to read this paragraph again. Just notice that we are back to creating a function to model the x value of point P. I'm not going to bother drawing a sketch of the graph this time because I'm noticing that all of the options are cosine functions with a positive a value, so the graph won't really help me choose between them. Each of these options have a different b value, so I'm going to go straight to the part where I calculate the b value based on the given information, and then I see which b value is a match. To find the b value, first we need the period. The period will be the duration of one rotation, and we are told that 4 rotations take 8 seconds. We can find the duration of one rotation by dividing both sides by 4. One rotation will take 2 seconds, so the period is 2 seconds. The b value is given by 2 pi divided by the period. So in this case, that's 2 pi divided by 2. The 2's cancel out, leaving a b value of pi. Aha! The answer is C. Number 21. The average high temperature in degrees Fahrenheit in a city for a given month is modeled by the function f on the closed interval from 0 to 12 months. The table gives values for the function f at selected values of t. A sinusoidal regression model, y equals a times the sine of bx plus c plus d, is used to model these data. Based on the sinusoidal model, what was the average high temperature to the nearest degree Fahrenheit at time t equals 6 months? So when they talk about a regression model, they're talking about using the calculator to find a curve of best fit. Let's all reset the calculator so we can start fresh. Hit second plus 712. Again, that's second plus 712. Now we have a fresh calculator. Hit the Stat button and hit Enter. We are going to enter the input values in L1 and the output values in L2. Once you have the data all typed in, hit the Stat button and switch over to the Calculate menu. The sinusoidal regression model is way down below option 9, so you will actually get there quicker if you scroll up like this. So you want this option right here. Always tell the calculator to store the regression model in Y1. So go down to this option and choose Y1 by hitting Alpha, Trace, Enter. Hit Enter a couple more times to calculate the regression model. And there it is. Notice that if you click on Y equals, you will find that the regression model has been stored for you in Y1. To estimate the average high temperature at t equals 6 months, we need to evaluate y at 6. So y1 at 6 on the calculator. Get to a blank screen by hitting second, quit. You can make y1 show up by hitting Alpha, Trace, Enter. You can evaluate y1 at 6 by putting 6 in parentheses like this and hitting Enter. So this is our answer, but we were told to round to the nearest whole degree. So that's 81 degrees. So the answer is C. Number 22 is basically the same thing. So pause the video and try to do number 22 by yourself. Then hit play and see how you did. Okay, I'm going to assume that you did that. So, to the calculator. Let's reset again. Clean slate. We do second plus 712. Memorize that. So now we hit Stat and Enter, and we will enter the input values in L1 and the output values in L2. Once you have all your data typed in, hit the Stat button, switch to the Calculate menu, and scroll up until you get to Sinusoidal Regression. Right here, and hit Enter. Tell your calculator to store the regression equation in Y1 by hitting Alpha, Trace, Enter right here. Hit Enter a couple more times, and kabam! There's your regression model, which has also been stored for us in Y1. We are using the regression model to estimate the height of a remote-controlled drone at time t equals 21 seconds. So we need to evaluate y1 at 21 on the calculator. We can pull up y1 by hitting Alpha, Trace, Enter. And we can evaluate y1 at 21 by putting 21 in parentheses like this and hitting Enter. 35.4108. To the nearest tenth, that's 35.4 feet. So the answer is B. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.